Hello and welcome to another video on chemistry revision. Today we shall continue our topic on redox and we shall focus on oxidation and reduction in terms of changes in oxidation state. Okay, now you would have seen in the previous videos that oxidation can be defined as a gain of oxygen, a loss of hydrogen, or a loss of electrons, whereas reduction being the exact opposite of oxygen. Reduction is a loss of oxygen, a gain of hydrogen, or a gain in electrons. So today we are going to focus on oxidation and reduction in terms of changes in oxidation state. So the definition is that a substance is oxidized when its oxidation state increases, and a substance has been reduced when its oxidation state decreases. Okay, now in the previous videos we have gone through how to assign oxidation states of elements in various substances. So today we shall use several examples to go through this fact. Okay, so the question is, explain in terms of oxidation states which substance has been oxidized and which substance has been reduced. So in this first reaction we can see that hydrogen reacts with oxygen to form water. All right, you can recognize that this is actually a combustion reaction. Okay, so now in order for us to determine whether something has been oxidized or reduced, we first check its oxidation state. Okay, so we can see here hydrogen is in its elemental form. Okay, hydrogen being an element, the oxidation state will be 0. Oxygen here is also an element, so its oxidation state is also 0. Now we look at water. Now hydrogen and oxygen don't usually change their oxidation states, so we can assign oxygen typically in a compound would have an oxidation state of -2, whereas hydrogen here would have an oxidation state of +1. However, since there's 2 of hydrogens, we have to multiply it by 2. Alright, so this gives us a total of +2, which balances off the -2, because as you would remember, the oxidation state of a compound overall should be 0. Okay, so now let us see how the oxidation state of hydrogen has changed. We can see that the oxidation state of hydrogen has gone from 0 to +1, and we see that 0 changing to +1 is actually an increase in the oxidation state, which means an increase in the oxidation state of a substance means the substance has been oxidized. Right? So this is an oxidized. Now if we were to just change the pen color now and take a look at what happens to oxygen, the oxidation state of oxygen has gone from 0 to -2. 0 changing to -2, which means this is a decrease in the oxidation state. And if you can recall, when the substance oxidation state has decreased, the substance has been reduced. Okay, so we can say that has been reduced. So now let us focus on oxygen and hydrogen first. We can say that the oxidation state of hydrogen has increased from 0 in H2, which we can see here. It was 0 when it was in hydrogen, the element form, and it has increased to +1 in water. Okay, so we say again that the oxidation state of hydrogen has increased from 0 in hydrogen to +1 in water. And because the oxidation state of hydrogen has increased, we say that hydrogen has been oxidize to water. Okay, now as usual, when something has been oxidized, usually something else is reduced. So now let's take a look at oxygen. We can see that the oxidation state of oxygen has actually decreased from 0 to -2. So let us write that properly. The oxidation state of oxygen has decreased from, what did it start off? It started off as 0 in oxygen, which was here, and it decreased to -2 in water, -2 in H2O. So we can say that since oxidation state of oxygen has decreased, we know that it has been reduced. So oxygen has been reduced to water. Okay, now the format that I have shown here is the way that you should follow when answering questions in the exam or in the test. Okay, so let us do another example and see whether we can apply the same concept. We take a look at the reaction between iron 3 oxide and carbon monoxide to give you iron and carbon dioxide. Now you would recognize this reaction, this equation, from the topic of the extraction of metals. This is the actual equation where we get the molten iron from the hematite. Okay, so in order for us to determine which substance has been oxidized and which substance has been reduced, we first assign oxidation states to each element in the equation. So let's take a look at iron 3 oxide. Okay, now as we know, typically the oxidation state of oxygen doesn't change, so we would assign that first. Oxygen would have an oxidation state of -2, and since there's 3 of oxygen, we would multiply it by 3. This would give us overall -6. Now the -6 would definitely have to be balanced off with a +6, because as you would have recalled, the overall oxidation state of a compound must be 0. Now because there's 2 of iron, we have to multiply the oxidation state of iron here by 2. That would leave us the oxidation state of iron in iron 3 oxide is +3. Okay, now you would recall that this compound here is actually iron 3 oxide, and you would now be able to conclude that the 3 here actually represents the oxidation state of iron in iron 3 oxide. Okay, now let us go to carbon monoxide. We know, again as usual, oxygen typically has an oxidation state of -2, and that would mean the oxidation state of carbon in carbon monoxide is a +2. Let's take a look at the iron. This iron here is in its elemental form, and if you recall, the oxidation state of elements is 0. So now let us take a look at carbon dioxide. Typically, again, oxygen, oxidation state of -2. Since there's 2 of them, we multiply it by 2, giving us a total of -4, which means the oxidation state of carbon here would be +4, since the overall oxidation state has to be 0. Now, before we continue to determine which substance has been oxidized and reduced, I would like to point out one thing. Look at the carbon monoxide. Notice that when I determine the oxidation states of the elements in carbon monoxide, I do not multiply it by 3. Okay, similarly, iron here, the 2 in front doesn't play a part in determining the oxidation state. Similarly, for carbon dioxide, I looked at the individual oxidation states of the elements in the compound, and I do not do anything to the number 3 in front here. I do not use that at all. Okay, just to be clear, when we determine oxidation states of elements in a compound, we just look at the molecular formula only. Okay, so now that we've assigned all the oxidation states, let us take a look at what has changed. So I'll use a different color. Let's take a look at iron. Iron has changed from an oxidation state of +3 to 0. Okay, so let me just do another one here so that you're clear. Now the oxidation state of iron has changed from +3 to 0, which means since the number has gone down from +3 to 0, this means that there was a decrease in the oxidation state. That means the substance has been reduced. So we can say that the oxidation state of iron has decreased. Okay, what did it decrease from? It decreased from +3 in, what was the name of the compound? In Fe2O3. It started off at +3 and then it decreased to 0 in iron. You can see that the oxidation state of iron here in the final compound, in the final reaction is 0. So we say that Fe2O3 or iron trioxide has been reduced to iron. Okay, now we notice that we say that the entire compound has been reduced to iron. Okay, and notice one more thing, we do not say iron trioxide has been reduced to 2 iron, which is the ratio in front of the iron. Notice that we do not write this down. We just write it has been reduced to iron. Okay, just another quick point out. Okay, so now if iron has been reduced, iron trioxide has been reduced, something must be oxidized. So let's take a look at the different other elements and see what other element has changed its oxidation number. The oxidation state of oxygen didn't change, it was -2, -2, -2. But you will notice that the oxidation state of carbon has changed from +2 to +4. So it has changed from +2 to +4, which means it has increased, which means the substance has been oxidized. So let us write that statement. The oxidation state of carbon, now notice when I say the oxidation state of something, it is always the element. Okay, but we say the oxidation state of carbon has increased. Now it increased from what? It increased from +2. Where was the +2? It was in carbon monoxide. Again, notice that I did not write the 3 in front of the carbon monoxide. And it increased to +4. Where was the carbon in the +4? In CO2 or carbon dioxide. So we say that the oxidation state of carbon has increased from +2 to carbon monoxide, from +2 in carbon monoxide to +4 in carbon dioxide. So since the number oxidation state has increased, we say that carbon monoxide has been oxidized to carbon dioxide. Okay, let us do one last example and take a slightly different reaction. Now you notice that magnesium reacts with 2H plus to give you magnesium ions and hydrogen gas. Now this is actually the ionic equation for the reaction of a metal with an acid. So to determine which substance has been oxidized and which substance has been reduced, again we assign oxidation states first. We can see that magnesium here is in its elemental form. So all elements have an oxidation state of 0. H plus here is in an ion, and you remember that the oxidation state of the ion corresponds to the charge. So the H plus here has an oxidation state of +1. Okay, now since there's 2 of them, we can also write multiply by 2. Magnesium here is an ion. You can see that the charge is 2 plus, so the oxidation state of magnesium ion here is +2. And now we come to hydrogen gas. We see that hydrogen gas here, H2, is in its elemental form, which means the oxidation state of the element would be 0. Now, before I continue, I want to emphasize again that when we write charge, we write the charge as 2 plus, but when we write oxidation state, we write it as +2. Okay, so when we are writing charges, the number comes before the sign, but when we are writing oxidation states, the sign comes before the number. Okay, so now let us take a look. What has changed? Automatically we can see that the oxidation state of magnesium has changed from 0 to +2. Now this is an increase in the oxidation state, which means magnesium has been oxidized. So let us write the oxidation state of magnesium has increased. Now what did it increase from? It increased from 0 in magnesium, which was here, and it increased to +2. Where was this +2? In Mg2 plus. So we say that since the oxidation state has increased, the oxidation state of magnesium has been oxidized to magnesium 2 plus. Okay. Now, like I said before, when something has been oxidized, something always has to be reduced. And you will see that the only other change that has happened was that the oxidation state of hydrogen has changed from +1 to 0. And you would recognize that this is a decrease, which means it is a reduction. So, how shall we phrase the answer? We say that the oxidation state of hydrogen, again, we're talking about the element, oxidation state of hydrogen has decreased from what to what? It decreased from +1 in H plus. Again, you notice that I did not write the number 2 in front of the H plus. So it decreased from +1 in H plus to 0 here in H2. So we know that since the oxidation state has decreased, we say that H plus has been reduced to H2, hydrogen gas. Okay, so this is the last example that we will show. So just a quick summary. In order for us to determine what has been oxidized and what has been reduced, we need to first of all determine the oxidation states of all the different elements within that reaction, assign the oxidation states following the rules that we have discussed previously, determine which element has increased in oxidation state and which element has decreased in its oxidation state. And we remember that when the oxidation state has increased, we say that it has been oxidized. When an oxidation state of a substance has decreased, we say that it has been reduced. Okay, so this is an example of redox in terms of oxidation states. So I hope that this video has been useful to you. All right, do pause and replay it back again if you think that you need to take it a little bit slower. All right, thank you. Bye bye.